Question 1. Given the circumstances, Mr. Franken is installing a new refrigerant piping system that requires both high corrosion resistance and excellent thermal conductivity. He is considering using copper and steel pipes in different sections. What should Mr. Franken prioritize when deciding between copper and steel pipes for various parts of the system? A. Use steel pipes for all sections due to their superior thermal conductivity. B. Use copper pipes for sections exposed to corrosive environments and steel where strength is critical. C. Use copper pipes where flexibility is required and steel pipes for ease of installation. D. Use steel pipes exclusively because they are easier to weld and join. Answer. Correct answer. B. Explanation. Copper is preferred in sections exposed to corrosive environments due to its corrosion resistance and superior thermal conductivity, which aids efficient heat transfer. Steel pipes, while stronger and more suitable for high-pressure applications, are more prone to corrosion unless properly treated. Flexibility or installation ease does not outweigh material properties critical to system longevity and safety. Therefore, resistance to corrosion is paramount in certain system parts and steel's strength is essential in others, aligning with best piping practices. Question 2. From the perspective of pipe sizing, is tasked with designing refrigerant piping for a large commercial chiller system. She notices that increasing the pipe diameter reduces velocity but increases the cost. How should Is approach the pipe sizing to ensure optimal performance? A. Select the smallest pipe size possible to minimize cost and rely on high pressure to push refrigerant. B. Use the largest pipe diameter to reduce velocity and pressure drop regardless of cost. C. Balance pipe diameter to maintain refrigerant velocity within manufacturer guidelines to minimize pressure drop and noise. D. Choose pipe sizes based on aesthetic preferences and available fittings. Answer. Correct answer. C. Explanation. Proper pipe sizing balances velocity to reduce pressure drop and noise without overspending on unnecessarily large piping. Too small, a pipe increases velocity, causing higher friction losses and noise, while oversizing inflates costs and complicates installation. Industry standards and manufacturer guidelines define acceptable velocity ranges to optimize system efficiency and longevity. Aesthetic or arbitrary choices ignore critical performance criteria, which can lead to operational issues. Question 3. During the process of brazing copper refrigerant lines, Mr. Gomez notices uneven heating and oxidation on the pipe surface. What is the best practice Mr. Gomez should follow to ensure a reliable brazed joint? A. Heat only one side of the joint until the brazing filler melts. B. Clean both joint surfaces thoroughly and heat evenly to allow capillary action of the filler. C. Apply filler before heating the joint to speed the process. D. Use excessive flux to compensate for unclean surfaces. Answer. Correct answer. D. Explanation. Although cleaning and even heating are essential to brazing, relying on excessive flux to compensate for unclean surfaces is poor practice. Proper cleaning removes oxides and contaminants, and heating both surfaces evenly ensures the brazing filler flows by capillary action, producing a strong, leak-proof joint. Applying filler prematurely or heating unevenly can lead to weak joints or incomplete bonding. Excess may cause contamination and weak spots in the joint. Question 4. Considering the evidence from recent HVACR installations, which valve type should Mr. Nguyen use for isolating sections of refrigerant piping with minimal pressure drop and easy operation? A. Ball valve. B. Gate valve. C. Globe valve. D. Check valve. Answer. Correct answer. A. Explanation. Ball valves provide quick, reliable isolation with minimal pressure drop because their full-bore design allows unobstructed flow when open. Gate valves take longer to operate and can cause more turbulence, while globe valves inherently produce higher pressure drops due to their flow path. Check valves serve different purposes, preventing backflow, and are not suitable for isolation tasks. Selecting valves that maintain efficiency and operational ease is crucial. Question 5. When faced with a scenario where the piping layout must minimize refrigerant oil trapping, Isa Patel reviews the system design. Which of the following practices is most effective to prevent oil logging in horizontal refrigerant suction lines? A. Use long, continuous horizontal runs without support. B. Install suction line traps or vertical risers at low points to collect and return oil. C. Increase pipe diameter to reduce velocity and oil accumulation. D. Use flexible hoses instead of rigid pipes for better oil movement. Answer. Correct answer. C. Explanation. Increasing pipe diameter reduces refrigerant velocity, which can contribute to oil settling and logging rather than preventing it. The best practice is installing suction line traps or vertical risers at strategic low points to promote oil return to the compressor. Long unsupported runs increase sagging and potential oil pockets. Flexible hoses do not inherently improve oil return and may introduce other mechanical issues. Proper layout and traps are essential for oil management. Question 6. Under the assumption that a refrigerant system uses R400 TINA and operates at higher pressure compared to older refrigerants, what piping material considerations should be prioritized by Mr. Lewis? A. Use only plastic pipes because they are cheaper and easier to install. B. Select piping materials rated for higher operating pressures and ensure proper thickness and joints. C. Use standard copper pipes without any pressure considerations. D. Use aluminum pipes because they are lightweight and compatible with all refrigerants. Answer. Correct answer. D. Explanation. Although aluminum is lightweight and used in some systems, it is not universally compatible with all refrigerants or suitable for all high-pressure applications. The most important consideration is selecting piping materials rated to handle the system's higher operating pressures, typically involving thicker copper or steel pipes, and ensuring joints can withstand pressure. Plastic pipes are generally unsuitable for high refrigerant systems. Copper pipes without proper rating may fail under pressure. Question 7. Within the framework of leak testing, Mr. Davis uses nitrogen pressure testing on the newly installed piping system. What must Mr. Davis consider to ensure the test accurately detects leaks without damaging the system? A. Use the highest possible pressure to quickly find leaks regardless of system rating. B. Pressurize the system with nitrogen to a level not exceeding the design pressure and monitor for pressure drops. C. Use water for pressure testing instead of nitrogen to avoid safety concerns. D. Perform the test only after the system is fully charged with refrigerant. Answer. Correct answer. C. Explanation. While water pressure testing can be used, it may cause corrosion and is generally avoided in refrigerant piping systems. Nitrogen is preferred because it is dry, inert, and safer for pressure testing. However, pressure should never exceed the design limits to prevent pipe damage. Testing after full refrigerant charging is unsafe and impractical. Monitoring for pressure drops at proper test pressures ensures leak detection with compromising system integrity. Question 8. In light of recent developments in pipe insulation techniques, Kim is installing insulation on chilled water piping in a humid climate. What is the most critical factor Kim must address to prevent condensation and energy loss? A. Choose the cheapest available insulation regardless of thickness. B. Ensure the insulation is vapor barrier rated and properly sealed to prevent moisture ingress. C. Apply insulation only on vertical pipes to save materials. D. Use insulation with high thermal conductivity to improve heat transfer. Answer. Correct answer. B. Explanation. Preventing moisture ingress is essential in humid climates to avoid condensation on chilled water piping. Insulation must have a vapor barrier and be sealed at joints and penetrations. Using cheap insulation without vapor barriers or applying only selectively can lead to condensation and mold growth. Insulation with low thermal conductivity is designed to minimize heat gain, not high conductivity, which increases heat transfer. Question 9. Throughout the course of a complex commercial HVACR project, Mr. Brown needs to interpret piping schematics for troubleshooting. What key approach should he apply to accurately diagnose issues based on blueprints? A. Focus only on the layout of pipes without considering component function. B. Understand the flow, direction, pressure points, and how components interact within the system. C. Use color codes exclusively to identify problems. D. Rely on approximate locations rather than exact blueprint details. Answer. Correct answer. C. Explanation. Relying solely on color codes is insufficient as they may vary between projects and don't convey system dynamics. Accurate diagnosis requires understanding flow paths, pressure zones, and interactions of components like valves and compressors as shown in the blueprint. Approximations lead to misdiagnosis. Detailed schematic analysis combining layout and functional knowledge is crucial for effective troubleshooting. Question 10. Taking into account the principles of pipe bending and forming, Mr. Ortega must install a piping room with several type bends but is concerned about maintaining pipe integrity. What should Mr. Ortega do to ensure the pipe's structural and flow performance? A. Use small radius bending method to save space, ignoring wall thinning. B. Select proper bending techniques with adequate radius to minimize pipe deformation and maintain flow. C. Avoid bending and use multiple fittings instead to achieve direction changes. D. Heat the pipe excessively to allow sharper bends without damage. Answer. Correct answer. B. Explanation. Proper bending requires maintaining a minimum bend radius to prevent wall thinning, cracking, or kinking, which compromise structural integrity and fluid flow. Using fittings for all changes increases leak points and pressure drops. Excessive heating risks metallurgical damage. Correct bending techniques balance space constraints with mechanical integrity and system efficiency. Question 11. In the context of safety and regulations, Harper is preparing to enter a confined space where refrigerant piping is installed. Which safety procedure should she prioritize to ensure a safe working environment? A. Ventilate the space thoroughly and test for oxygen levels before entry. B. Rely on personal protective equipment alone without monitoring air quality. C. Enter immediately and plan to ventilate if any symptoms occur. D. Only inform supervisors after entering the space. Answer. Correct answer. A. Explanation. Confined space entry requires proper ventilation to reduce hazardous atmospheres and oxygen monitoring to ensure safe breathing conditions. PPE is important but insufficient alone. Entering without air quality testing is extremely dangerous, risking suffocation or poisoning. Informing supervisors before entry and following lockout-tagout procedures are also essential. Prioritizing ventilation and air testing aligns with OSHA and industry best practices to prevent accidents. Question 12. According to recent studies on pipe threading, Mr. Sanders notices that improper threading can cause leaks in refrigerant piping joints. What is the best practice Mr. Sanders should follow to ensure leak-free threaded connections? A. Use Teflon tape or thread sealant appropriately on male threads and tighten to manufacturer torque specifications. B. Tighten joints as much as possible without sealant to ensure tightness. C. Avoid threading pipes and use only welded joints. D. Apply excessive sealant to compensate for poor threading. Answer. Correct answer. D. Explanation. Proper threading combined with appropriate use of Teflon tape or sealant and correct torque ensures leak-free joints. Over-tightening can damage threads and cause leaks, while excessive sealant can clog pipes or fail to seal properly. Welding is suitable for some applications, but not always practical or necessary. Applying excessive sealant masks poor workmanship and may create long-term reliability problems. Question 13. From the perspective of heat transfer, Mr. Clark is asked to reduce heat gain in refrigerant piping exposed to ambient air. Which insulation principle should guide Mr. Clark's approach? A. Use insulation with low thermal resistance to allow heat flow. B. Use materials with high thermal resistance and vapor barriers to minimize conductive and convective heat transfer. C. Use reflective surfaces without insulating materials to reflect heat radiation only. D. Rely on pipe color to dissipate heat naturally. Answer. Correct answer. B. Explanation. Effective insulation minimizes heat transfer primarily through conduction and convection by using materials with high thermal resistance R-value. Vapor barriers prevent moisture ingress, which degrades insulation performance. Reflective surfaces reduce radiant heat but are insufficient alone. Pipe color affects heat radiation slightly but does not replace proper insulation. Thus, combined insulation and vapor barrier are industry best practice to reduce heat gain. Question 14. Given the circumstances, Mr. Jensen must select a piping fitting for a branch line requiring a 90-degree directional change with minimal pressure loss. Which fitting type should Mr. Jensen choose? A. Sharp 90-degree elbow. B. Long radius elbow. C. T-fitting with a perpendicular branch. D. Coupling fitting. Answer. Correct answer. C. Explanation. T-fittings create a branch connection but inherently cause more pressure loss due to flow disruption. For directional changes, long radius elbows are preferred over sharp elbows because they reduce turbulence and pressure drop. Couplings join pipes inline without changing direction. While T's are necessary for branching, minimizing pressure loss favors using long radius elbows for directional changes. Question 15. Considering the evidence, is Ortiz troubleshooting a refrigerant piping system showing signs of oil logging in the compressor? What corrective action should she take to address the issue? A. Decrease refrigerant velocity in suction lines to promote oil return. B. Install additional oil separators and adjust piping to improve oil return pathways. C. Increase pipe insulation thickness to trap heat and prevent oil condensation. D. Use smaller diameter pipes to increase velocity and move oil more quickly. Answer. Correct answer. A. Explanation. Oil logging occurs when oil does not return to the compressor, causing operational issues. Increasing refrigerant velocity within recommended ranges helps carry oil back. Smaller pipes raise velocity but risk excessive pressure drop. Adding oil separators assists oil removal but does not fix improper piping layout. Insulation prevents condensation but does not directly solve oil return problems. Correct velocity management and piping design are critical. Question 16. When evaluating the merits of different welding methods for steel pipe joining, Mr. Ramirez must choose the most suitable process for high-pressure refrigerant systems. Which welding process is most appropriate? A. MIG welding for quick and easy welds. B. TIG welding for precise, high-quality welds with better control. C. Stick welding because it is the cheapest method. D. Brazing to avoid high heat input. Answer. Correct answer. B. Explanation. TIG welding provides excellent control, clean welds, and superior strength. Ideal for high-pressure steel piping in refrigerant systems. MIG welding is faster but less precise and can introduce impurities. Stick welding is less suited for thin or precise piping welds due to slag and lower quality. Brazing is appropriate for copper but not steel high-pressure joints due to lower strength. Selecting the best method ensures integrity under pressure. Question 17. The underlying principle of pressure and temperature relationships is crucial in refrigerant piping. Simmons notes that increasing the system pressure leads to a primary effect on refrigerant temperature. A. Refrigerant temperature decreases as pressure increases. B. Refrigerant temperature remains constant regardless of pressure changes. C. Refrigerant temperature increases as pressure increases. D. Refrigerant temperature fluctuates randomly with pressure changes. Answer. Correct answer. C. Explanation. According to thermodynamic principles, increasing pressure generally raises the saturation temperature of a refrigerant, meaning the refrigerant boils or condenses at high temperatures. This relationship is fundamental to refrigeration cycles. Temperature does not remain constant nor fluctuate randomly with pressure. It follows predictable pressure-temperature curves for each refrigerant. Understanding this guides system design and diagnostics. Question 18. From a practical standpoint, Mr. Wallace must cut various pipes on site. Which tool choice and technique will ensure the most accurate and clean cuts for copper refrigerant piping? A. Use a hacksaw with no support, cutting freehand. B. Use a pipe cutter designed for copper tubing and rotate evenly until the cut is complete. C. Use an angle grinder with a metal cutting disc for speed. D. Use a torch to melt through the pipe quickly. Answer. Correct answer. D. Explanation. Using the torch to cut copper tubing is unsafe, imprecise, and damages pipe ends, leading to poor joints. A pipe cutter designed for copper tubing provides clean, square cuts without deforming the pipe, essential for good brazing or fitting connections. Hacksaws risk uneven cuts, and grinders may overheat or damage pipe ends. Best practice dictates using proper copper tubing cutters and technique for accuracy. Question 19. In the modern context of refrigerant handling, Patel must safely recover refrigerant from the system before piping modifications. What is the most critical step in this recovery process? A. Vent refrigerant into the atmosphere to expedite work. B. Use approved recovery equipment and capture refrigerant without leaks. C. Open the system and allow refrigerant to dissipate naturally. D. Mix refrigerants to reduce recovery time. Answer. Correct answer. A. Explanation. Venting refrigerants into the atmosphere is illegal and environmentally hazardous due to ozone depletion and global warming potential. Safe refrigerant recovery requires approved equipment designed to capture and store refrigerants properly for reuse or disposal. Opening systems without recovery causes loss and contamination. Mixing refrigerants damages equipment and complicates disposal. Compliance with EPA and environmental regulations is mandatory. Question 20. During pipe layout design, ISTACHIM is tasked with minimizing material waste and maximizing system efficiency in a multi-floor building. Which design principle should guide its piping runs? A. Use the longest possible piping runs to reduce the number of fittings. B. Plan piping runs to minimize total length and use risers efficiently with minimal bends. C. Use many small diameter pipes instead of fewer large diameter pipes. D. Ignore building architecture to simplify piping paths. Answer. Correct answer. B. Explanation. Efficient pipe layout reduces total pipe length and fittings, lowering material costs and pressure losses. Proper use of risers and minimal bends improves flow and reduces installation complexity. Longer runs increase pressure drop and waste materials. Using many small pipes can complicate the system and increase costs. Ignoring building layout risks conflicts and inefficiencies. Optimal layout balances practical constraints with hydraulic design. Question 21. In the context of pipe fittings, Mr. Matthews needs to select the appropriate fitting to change the direction of refrigerant piping by 45 degrees while minimizing pressure loss. Which fitting should he choose? A. 45-degree elbow. B. 90-degree elbow. C. T-fitting. D. Coupling. Answer. Correct answer. A. Explanation. A 45-degree elbow provides a gentler directional change than a 90-degree elbow, resulting in low pressure loss and reduced turbulence. T-fittings are used for branching, not direction changes, and couplings connect straight pipes without altering direction. Selecting the fitting that balances directional change and flow efficiency is key to maintaining system performance. Question 22. From the perspective of refrigerant piping safety, Is Gomez observes a brazing operation on copper pipes. What is the most important safety precautions you should enforce during this process? A. Ensuring adequate ventilation and wearing appropriate PPE to prevent inhalation of fumes. B. Rushing the brazing to reduce exposure time. C. Brazing only in enclosed spaces to contain heat. D. Using water to cool the pipe immediately after brazing. Answer. Correct answer. C. Explanation. Brazing in enclosed spaces without ventilation is hazardous due to toxic fumes and fire risk. Adequate ventilation and PPE like gloves and respirators protect workers from exposure. Rushing brazing compromises joint quality, and rapid cooling with water can cause thermal shock and damage. Proper procedures ensure safety and quality. Question 23. Given the circumstances of a refrigerant system operating under variable load, Mr. Patel needs to size the suction piping. Which principle should guide his pipe sizing decision? A. Size pipes to maintain refrigerant velocity within recommended ranges to ensure oil return and avoid noise. B. Use the smallest diameter possible to save material costs. C. Oversize pipes significantly to reduce velocity below recommended minimums. D. Select pipe size based on the largest available fittings. Answer. Correct answer. B. Explanation. Using the smallest diameter pipe may increase velocity beyond recommended limits, causing noise, pressure drop, and oil return problems. Oversizing reduces velocity excessively, risking oil logging. Pipe sizing should maintain velocity within a specified range, balancing efficiency and reliability. Choosing sizes based on fittings or costs without hydraulic consideration risks system failure. Question 24. While examining the relationship between pressure and temperature in refrigerant systems, Reynolds notes that pressure relief valves are critical. What is the primary function of these valves? A. To maintain system pressure within safe limits by releasing excess pressure. B. To increase system pressure for better cooling. C. To prevent refrigerant flow during compressor shutdown. D. To regulate refrigerant temperature directly. Answer. Correct answer, D. Explanation. Pressure relief valves protect the system by releasing excess pressure to prevent overpressure damage. They do not increase pressure or regulate temperature directly, nor do they control refrigerant flow during shutdown. Maintaining safe operating pressures is essential to system safety and compliance with codes. Question 25. Considering practical pipetting skills, the steward must bend copper tubing to fit a compact layout without kinking. Which technique should he use? A. Heat the pipe extensively before bending. B. Use a pipe bending spring or bending tool to maintain shape. C. Bend the pipe sharply by hand without tools. D. Cut and rejoin with fittings instead of bending. Answer. Correct answer, A. Explanation. Heating copper tubing before bending softens the metal and helps prevent kinks. Using bending springs or tools is also effective and typically preferred for precision, sharp manual bends without support cause damage, and cutting with fittings increases leak potential and complexity. Proper bending technique preserves pipe integrity and flow. Question 26. When evaluating piping standards, Jackson is tasked with ensuring compliance for a new installation. What is the best approach for her to confirm the piping meets required codes? A. Reference applicable industry standards such as ASME and local regulations during design and inspection. B. Rely solely on installer experience without reviewing codes. C. Use any piping materials as long as they are cheap and available. D. Skip documentation for faster approval. Answer. Correct answer, B. Explanation. Relying solely on experience without consulting standards risks non-compliance and unsafe installations. Industry codes and local regulations govern materials, methods, and safety. Proper referencing during design and inspection ensures quality, legality, and system longevity. Cheap or undocumented installations often fail inspections and jeopardize safety. Question 27. In a troubleshooting scenario, Mr. Lopez finds an unusual pressure drop-in, a refrigerant suction line, which cause is most likely based on piping design principles. A. Excessive pipe length or too many fittings causing friction loss. B. Pipe diameter being too large. C. Properly sized straight pipes with minimal bends. D. Correct insulation applied on the suction line. Answer. Correct answer, A. Explanation. Long pipe runs and multiple fittings increase friction losses, causing pressure drops that reduce system efficiency. Oversized pipes reduce velocity but generally do not cause excessive pressure drops. Properly sized straight pipes and good insulation contribute to optimal performance. Identifying friction losses guides corrective design adjustments. Question 20. Demonstrated by industry best practices, Mr. Evans is applying insulation to refrigerant piping exposed to outdoor conditions. What insulation characteristic is critical for durability and performance? A. Resistance to moisture absorption and UV degradation. B. Being the thinnest available to save costs. C. Open cell foam to allow airflow. D. High thermal conductivity to transfer heat efficiently. Answer. Correct answer, A. Explanation. Insulation exposed outdoors must resist moisture absorption to prevent degradation and maintain thermal resistance. UV protection prevents material breakdown from sunlight. Thin insulation sacrifices effectiveness, and open cell foam allows moisture ingress. Low thermal conductivity, not high, is desired to minimize heat transfer and energy loss. Question 29. The common thread among refrigerant piping leak testing methods is the need for accuracy. Silver uses electronic leak detectors. What is a limitation she must keep in mind? A. Electronic detectors cannot detect all types of refrigerants equally well and may give false positives. B. They work perfectly in all environments without calibration. C. They are cheaper than soap bubble tests. D. They are effective only on large leaks. Answer. Correct answer, C. Explanation. Electronic leak detectors require calibration and may not detect all refrigerants equally, with false positives possible from environmental interference. They are generally more expensive than soap bubble methods. They detect small leaks effectively, not just large ones. Understanding limitations ensures proper testing and reliable diagnosis. Question 30. To better understand piping layout design, Mr. Bennett is asked why minimizing the number of fittings in a refrigerant piping system is important. What is the best explanation? A. Fittings increase pressure drop, potential leak points, and installation complexity. B. Fittings improve refrigerant flow and system reliability. C. More fittings reduce material costs. D. Using many fittings speeds up installation. Answer. Correct answer. D. Explanation. Minimizing fittings reduces pressure drops caused by turbulence, lowers leak risk, and simplifies maintenance. More fittings generally increase material costs and potential failures. Although fittings allow changes in direction and branching, excessive use compromises system efficiency and reliability. Speeding up installation by adding fittings is a poor trade-off.